video, hurry up.
Put the movie on.
Hurry up. And you're gonna be able to hear me on the video, so y'all don't be silly, okay? Alright, so linear, quadratic, and exponential. When m is greater than 0, what does that mean for m to be greater than 0? What is m in a linear function? The slope. So for it to say that m is greater than 0, what is that saying about the slope?
It's going up.
It's positive, correct? So it's going up. So m greater than 0 would look like this, moving up from left to right. So what would m less than 0 look like? Going down. On a quadratic function, it's in the shape of a what? A U, and if a is greater than 0, what direction does it open?
Up.
Up. And if it's less than 0,
Down.
it opens down. On an exponential, if you're b, now remember that your exponential is f of x equal a b to the x power. So if your b is greater than 1, it is growth. That means as it moves left to right, it's going up. And when it says the absolute value is between 0 and 1, it's decay. It means it's going down. And what else do we remember about exponential functions? What do they have that none of our other functions have? What's that line called? Remember? Asymptote. Remember that line that's never gonna be crossed? Alright, identifying functions, and I'm not gonna do all these, we're gonna just look at this really, really quickly. So, number 1, Abby, linear, quadratic, or exponential?
Quadratic. Wait, no, linear.
Linear. Chloe, number 2.
Exponential.
Alright, is it exponential growth or exponential decay? Growth. Alright, what about number 3, Brandy?
Quadratic.
Quadratic. Number 4, Annalise,
Exponential.
and is it growth or decay?
Decay.
Decay. How do we know that it's decay?
Because the number, that is being put to the x is less than 1.
That's right. What about number 5, Jesselyn?
Quadratic.
It is quadratic. How did you recognize that one as being quadratic?
Because it's factored.
Right, it's in factored form. And what is x times x? That'd be the very first thing we did. That makes it quadratic. Lily, number 6? Linear. Number 7, Daisy?
Exponential.
Exponential growth or exponential decay?
Growth.
Growth. How do we recognize it as being growth? This number right here, this is not a whole number, but what do we know about that number? It's greater than 1. Alright, Jasmine, what about number 8?
Wouldn't it just be a straight line?
It is making it just simply what? Linear. Would it be a vertical line or a horizontal line, Bella?
Vertical. No, horizontal, sorry.
Horizontal. This would be a horizontal line. Alright, number 9, Emma?
Quadratic.
Quadratic. How do you recognize it as quadratic?
Because it has a little exponential.
That's to the second power. What about number, Aurora, you got the hard one. What about number 10?
Quadratic.
It is quadratic. How do you recognize that it's gonna be quadratic?
Because I have to times it by x.
That's right. If you go through and multiply everything by x, you would get y equal x squared plus x, and that is quadratic. Good job. Leara, number 11.
Exponential growth.
Exponential growth. How do you know it's exponential growth? It's 6 to the power. Number 12, Mac. Linear. Number 13, now we're looking at the graphs. 13, Maddox.
Exponential.
Which one, growth or decay? Growth. Asher, number 14.
Linear.
Linear. Number 15, Abby. Quadratic. Turn over. Number 16, Chloe. If your choices are linear, quadratic, exponential, or none, what would the answer be?
No.
None. However, who recognizes what parent function this is? Daisy? How do you know that it's cubic?
It goes to 3 0.
It goes through 3 zeros, so this is actually a cubic function. Good job. Number 17, Brandy.
Linear,
Linear. Number 18, Annalise.
exponential decay.
Exponential decay. How do we tell in a table whether it's linear, quadratic, or exponential? Does anybody remember? What has to be true about linear?
Said you right.
It has a common what? First difference. So what is -6 minus -5? Minus a negative is the same as a what? Adding. So -6 plus 5 is -1. That's how we do it as a difference. But in reality, can we see that this is going down every time by 1? So this is called the first difference. Alright, on a quadratic, it has a common what? Second difference, so we have to do it twice. So we wanna go from, how does it change from -3 to 5, or what is 5 minus -3?
8.
8. What's 9 minus 5? 4. 9 minus 9?
0.
And 5 minus 9?
Negative 4.
-4. We just found the first difference. Do it again. To go from 8 to 4, it went what?
4.
Down 4. 4 to 0 went down 4. 0 to -4 went down 4. So this is your common second difference. All right, how do we recognize an exponential?
Multiplying.
Yes, a common ratio or a common factor. So it's being multiplied. So how can we tell what number's being multiplied by? Pick two numbers that are easy for you to do.
2 and 6.
What, yeah, so how do you go from 2 to 6? You're multiplied by what? 3. Now, boys and girls, if you have a decimal or a fraction as your common ratio, you have to be able to do it in the calculator. So everybody would you do 54 divided by 162 or 162 divided by 54?
162 divided by 54.
Yes, you just take two numbers, the bottom divided by top, and it'll give you your answer. Alright, but every one of these is being multiplied by 3. Alright, so now let's look at number 19. We have to decide linear, quadratic, or exponential. Jesslyn, looking at number 19, what's happening?
Is it quadratic?
It went -4, -6, -8, -10, so it's going down by what every time? 2. And your x values are going up by what? Going up by 4? Every time? Every time. That makes this what? Linear. Alright, look at number 20. Is it going up or down? Down. Boys and girls, can you tell by looking, this is not going down by a constant number, so it's definitely not linear? So you think it's exponential, Mac?
Yes.
Alright, so what's the common ratio for this?
3. Don't need to divide by 3.
So that would be multiplying by what? It's being multiplied by 1/3. 135 times 1/3 is 45. 45 times 1/3 is 15. 15 divided by times 1/3 is 5. So dividing by 3 is the same as multiplying by 1/3. So this one is exponential growth or exponential decay? Decay. Alright, 21. You see if you can figure this one out. And none is also an option, don't forget that, so don't think that it's not this one, it's not this one, so it has to be this, cause that's not the case. What are you doing, Mike? Come on.
I was just discussing.
You should have been discussing we tell very quickly it's not linear and it's not exponential? Yes, they're not adding the same number, they're not multiplying by the same number, so we need to,
That's
what we
exactly
have
what I
to
said.
check is quadratic. Did you check quadratic?
No.
Alright, so from -5 to 25 would mean it went up 30. From 25 to 59, it went up how much? 34, and from 59 to 97, how much did it go up? How much? 38. Alright, and then you have to check it again. From 30 to 34, it went up how many? 4, and from 34 to 38, it went up. So what does that make this?
Quadratic.
Quadratic. Y'all remember when I told you that you had to be careful about quadratic because they wouldn't always show in the y values the up and down? See, these are all just go strictly what? Up. So you can't just glance at it and say, hey, I recognize this as being quadratic. You have to actually check that common second difference. Alright, what about number 22?
Exponential growth,
Alright, how do you know it's exponential growth?
because it's getting multiplied by 4.
It's being multiplied by 4 every time, I agree. Alright, what about 23?
Linear,
Linear? What is the common difference?
it's getting added by 7.
Adding by 7 every time, I agree, that makes it linear. Alright, last one, 24. You figure out for sure. So, if you're gonna do this in a calculator, you wanna check linear first. 26 minus 14 is 12, 44 minus 26 is 18. And 44, that's 68. Minus 44 is 24. So 12, 18, and 24. Now, what's the common second difference?
6.
6, that makes this what?
Quadratic.
Quadratic. Alright, boys and girls, the Unit 9 homework 1 is an edge elastic, spelling, thank you.
I